All right, so that's kind of some analogies. That's hopefully getting us started with stoichiometry. Again, a lot of people can be a little nervous and have trouble with stoichiometry, so that's why I don't mind taking a little time to kind of get ourselves prepared on it. Now, again, what we're really looking for and what we need to be able to do is to go from moles of one thing, that's why the sub A, moles of one to moles of another. So moles of a reactant to figure out how many moles of the other reactant should be put together with it to give you a good reaction. Or the moles of reactant and how many moles of product are produced with that amount of moles of reactant. Okay? And so that's the real big nuts and bolts, going from moles to moles. That's our crossing of the bridge. Okay? The first thing that you need to be able to do when you go from moles of one to moles of another is you need a balanced chemical equation. You need a balanced chemical equation. And you're going to use the coefficients of that balanced chemical equation for your conversion factors. What we're going to be doing is we're going to be using the same idea, X line, X line, X line, thinking labels, and using the coefficients from our balanced equation for our conversion factors. Let's take a look at an example. Here's a very simple equation. Water is produced from the reaction of hydrogen and oxygen. I hope we're comfortable in the fact knowing that hydrogen needs to be H2 because hydrogen, whenever it's alone, it's not alone, it's a diatomic. Oxygen is also O2, but yet water is H2O. Okay? We then balance, and this is already balanced, we then balance by saying, let's cross these out and figure out how we balanced it. We have two hydrogens, we're okay, follows the law of conservation. Two oxygen, only one oxygen, so I would need two oxygens, but that just changed my hydrogens, so I would need two hydrogens as well on either side. So that's 4 on either side. So there's my balanced equation. What this coefficient basically says is, what we can say it says is, we can say that it's 2 moles of hydrogen to 1 mole, of course the no number in front represents 1 mole of O, and 2 moles of H2O. Simple enough. So if I say I want to know how to go from moles of one to moles of another, let's say I have 4 moles of hydrogen. How many moles of oxygen would be required to react with that? Hopefully we're comfortable taking this a shot here saying that 2, that's not a good choice of colors, that if I have 2 moles of oxygen, that's a 2-to-1 ratio in our balanced chemical equation, we're going to keep it a 2-to-1 ratio there. Now that would produce 4 moles of water. Notice we're keeping our 2-to-1-to-2 ratio. It's not simplified, but there you are. So what I basically did was I converted if I have 4 moles of hydrogen and I want to know how many moles of O2 would be reacted with that, notice really what I'm doing is an X line equation. I'm going to put moles of H2 in the denominator because that's what I'm given. Remember, we put the unit, the label of what we're given in the denominator, and we're going to put the label or the units of what we're looking for in the top, moles of oxygen. We use the coefficients for the conversion factors. So O2 is a 1, H2 is a 2. Notice that because it's 1/2 of 4, or in other words 4 divided by 2 is 2. And notice my label, my units becomes moles of O2 because the moles of H2 gets eliminated. It gets canceled out, dividing something by itself. All right, so that's the conversion. Now obviously that was very simple if it's 4, but we could have any. Moles to moles, as simple as it really sounds, is really quite simple as well. A mole to mole conversion is simply if I have oh, 13.29 moles of O2, and I want to know how many moles of H2O would be produced with that. So I'm giving you a certain amount of moles of O2, and I want to know how many moles of H2O that would produce. Again, just X line, moles O2, moles H2O. The label, O2 is 1. The coefficient for H2O is 2. We're going to multiply. I suppose I could do that in my head. 13.29, that would be 26.58 moles of H2O would be produced if you had 13.29 moles of oxygen. Okay? Moles, moles. When you did moles to grams, particles, or liters, the moles was always 1. It's always going to remain 1 when you're doing any of those conversions. Here is only where you're going to have a difference of 1, and that's always going to be dependent on what the coefficient of the balanced equation is.